Hello, dear students. Good morning, all of you. I hope you're all fine and doing well at home. So, due to coronavirus, no, we have to be home quarantined and we have to stay safe at home. So, we have few topics left out from the third unit and the sixth unit. I would like to discuss all those things now. I request each and every student to go through the classes regularly, all the video lectures which I post from now onwards. Right, earlier classes we have seen what is linearly separable pattern classification. To have a brief recap of what we have discussed about the linearly separable pattern classification, let us consider AND gate. You know the truth table for an AND gate. Let us consider a two input AND gate with x1 x2 as input and the output indicated as S. So according to this AND gate is AND is multiplication. So the output is for 0 0 0 1 1 0, the output is 0, and for 1 1 as inputs the output is 1. If I represent this in a pattern space, input pattern space, I hope you are able to recollect these. We have discussed all these things. If we were able to represent this in a pattern space, so this is 0 0, this point is 0 1 1 0, and this is 1 1. When 0 0 0 1 1 0 are the inputs, you can see the output is 0. That means for the inputs 0 0 0 1 1 0, the output is 0. Whereas for the input 1 1, the output is 1. I can divide this entire pattern space into two regions in such a way that, see here, I have drawn a line dividing the entire pattern space into two regions where 0 0 0 1 1 0 are on one side of this line, which indicates that all these input patterns belong to one class, and 1 1 on the other side of the line, or I call it as dichotomizer, okay, which separates the given region into two parts. And on the other side of this line, that is the right side of this line, 1 1 is available, which indicates that when 1 1 is the input, the output is 1. Okay, so output here is 1 and output here is 0. So I was able to divide the given pattern space into two regions, or else I was able to classify the given pattern space, given input patterns into two regions, okay, by a single straight line. I call this as linearly separable pattern classification. Okay, you can understand that. Linearly separable pattern classification. This is the entire pattern 0 0 0 1 1 0 1 1. I have divided this into two classes by a single line, which you call it as linearly separable pattern classification. I hope you have recollected this. If we consider the OR gate, same is the case with the OR gate also. Okay. So 0 0 0 1 1 0 1 1 are the inputs. OR is addition, and the outputs will be, for 0 0 as input the output is 0, whereas for 0 1 1 0 1 1 the outputs are 1. That means once again I was able to classify the given input pattern space into two regions. I hope you recollected the things. Okay, right now dear students, now let me explain you what is linearly separable pattern classification. So for that, let me consider, so for your comfort, I have prepared the slide before itself. For understanding this linearly non-separable pattern classification, let us consider XOR gate. You know, XOR is exclusively OR. Let us consider a two input XOR gate where x1 and x2 are the inputs. This is the truth table for the XOR gate. For 0 0 and 1 1, usually you know that XOR is x1 bar into x2 plus x1 into x2 bar. That means for 0 0 and 1 1 as input to the XOR gate, the output is 0. Whereas when the inputs are 0 1 and 1 0, the outputs are 1. Okay. So now let us draw the input pattern space. See here. So this is x1 axis, this is x2 axis. I have indicated 0 0, 0 1, 1 0, 1 1 input patterns. You know that from here 0 0 and 1 1 belong to one class, that is 0 0 and 1 1. See here, I indicated the input patterns as dots. 0 0 and 1 1 are indicated by dots, and 0 1 and 1 0 are indicated by cross, indicating that 0 0 1 1 belong to one class and 0 1 and 1 0 belong to another class. Obviously you can understand why, because 0 0 1 1 results in an output 0, 0 1 1 0 results in an output which is equal to 1. So now if that is the case, this and this belong to one class and this belong to another class. Now, can you divide the given input pattern space into two regions using a single line? Obviously, not at all possible. Why? Because see here, this and this belong to one class. I cannot draw a line like this where 1 1 falls on the other side, which is not correct. I cannot draw a line like this which indicates that 0 0 falls on the other side along with 0 1 1 0. Therefore, obviously I cannot divide the given input pattern space into two regions using a single line, hence it is called as linearly non-separable pattern classification. So what can I do now? What can I do now? So this is the XOR problem. XOR problem is solved by converting the given input pattern space into image space. Students, please try to understand XOR problem, this problem. So you cannot draw it with a single, you cannot separate it with a single straight line. So what I have to do, I have to convert the given input pattern space into the image space. I have to convert the given input pattern space into image space. Okay, where the image space, in the image space, you can divide the image space into two separate regions. That is linear separable pattern classification will be possible in image space. So what you are going to do now, I am going to convert the input pattern space into image space. That is nothing but, in other words, from linearly non-separable condition to linearly separable condition. So we'll see how it can be done. I hope you are able to follow me. Right, if you see this, so as I already told you, 0, 0, 1, 1 belong to one class. I have to separate these two pattern space, okay, using two lines. So let us consider, there is no general rule like I have to consider these points only, but let me consider it like this. Let me consider 2 points, minus 1 by 4, which is this point, and 0, 1 by 2. Draw a line, okay, and in the same way take another 2 points, 0, minus 1 by 2, 1 by 2, 0. Draw another line from these 2 points. So if you can see this and this is separating 0, 0, 1, 1. That means this entire region, this region corresponds to one class, which results in an output 0, and this region and this region, that is on the other side of the line 1 and 2, okay. So this is dividing, this particular region corresponds to the input patterns that results in an output 1, okay. So what I've done, I've considered two lines in such a way that the four input patterns are divided into two classes, okay, like this. Now minus 1 by 4, 0, 0, 1 by 2 are the 2 points corresponding to the line 1. You know that I can find out the equation of this straight line, okay, which is obtained as minus 2x1 plus x2 minus is equal to 1 by 2. That is nothing but minus 2x1 plus x2 minus 1 by 2 equal to 0. So that is the equation of the line, okay, right. I hope what is the formula to find out the equation of the line? So y minus y1 equal to m into x minus x1, where m is y2 minus y1 by x2 minus x1. So accordingly, if I find out the equation of this, the equation of the line passing through the points minus 1 by 4, 0, 1 by 2 is minus 2x1 plus x2 minus 1 by 2 equal to 0. Okay, so remember this. Next one, you can see the equation of the second line, which is passing through the points 0 minus 1 by 2, 1 by 2, 0. See that? 0, x-axis 0, minus 1 by 2, and 1 by 2, 0. What is the equation of the line passing through 0 minus 1 by 2, 1 by 2, 0? So it is nothing but x1 minus x2 minus 1 by 2 equal to 0. Okay, so I have obtained two equations. Let me name those two equations as O1 and O2. O1 already you can see, O1 is minus 2x1 plus x2 minus 1 by 2, minus 2x1 plus x2 minus 1 by 2 equal to 0, and O2 is x1 minus x2 minus 1 by 2 equal to 0. Since the logic gates operate with or the output of the logic gates are zeros and ones, let me consider a activation function which is a unipolar activation function, that is a signum function. That means whenever let me consider the signum function where x is the activation value, okay. So signum of x is equal to 1 whenever x value is greater than 0, and signum of x is equal to 0 whenever x value is less than 0, okay, right. So let me name these equations as O1 and O2, where O1 is a signum of minus 2x1 plus x2 minus 1 by 2, and O2 is signum of x1 minus x2 minus 1 by 2. So these are the two equations. Let me once again draw the table indicating x1, x2, O1, O2. So x1, x2 are the inputs, 0, 0, 0, 1, 1, 0, 1, 1. When x1, x2 are presented, what is O1? O1, see here, 0 0 is the input. Substitute O1 here, minus 2 into substitute x1 x2 here in O1, minus 2 into x1 is 0 plus 0 minus 1 by 2, signum of minus 1 by 2. What is signum of minus 1 by 2? That is 0. Okay, in the same way, 0 1, for 0 1 as inputs, 0 plus 1 minus 1 by 2, so that is minus plus 1 by 2. So signum of plus 1 by 2 is 1. For 1 0 as input, so minus 2 plus 0 minus 1 by 2, minus 2.5, which is nothing but signum of minus 2.5 is 0. In the same way, for 1 1, O1 is 0. In the same way, O2, see here, 0 0, for x1 x2 as 0 0, 0 minus 0 minus 1 by 2, so that is signum of minus 1 by 2, which is 0. In the same way, if I find out O2 for the remaining inputs, it is 0 1 0 like this. So O1 O2 are obtained corresponding to x1 and x2 as shown here. Okay, let us discuss about the pink colored lettering later on. Okay, I hope you understood up to this portion. Now let us draw the indicate this O1 O2 in the pattern space, in the image space, sorry. Okay, this is called as the image space. What you are doing here, pattern space is converted into image space. Okay, right, so see here, so O1 and O2 corresponds to the x and y axis elements. So see here, 0 0 1 0 0 1 0 0, there is no 1 1 here. Okay, see here, see, this is 0 0, this is 1 0, this is 0.01, and once again 0 0, right? So I have 3 points. Okay, now I can divide these two, belong to, obviously you know that 0 1 1 0 belong to one class. Okay, obviously these two can be separated. Now you have seen here, the entire pattern space can be divided into two regions in such a way that 0 1 1 0 belong to one class and 0 0 belong to another class using a single straight line. Okay, so let me consider 2 points for drawing this straight line, which are plus 1 by 2 0 and 0 1 by 2. Okay, and draw the line. So this is the line separating the given elements in the image space into two regions. Okay, right? So this is called as the image space. So what we have done here, the pattern space is converted into image space. How is the pattern space? Pattern space is, this is a nonlinear separable pattern classification. This is converted into image space, which is now a linearly separable pattern classification. Okay, right? Now, so see here. Now let us try to find out the equation of the straight line passing through the points 0 1 by 2 1 by 2 0. It is O1, because x and y axis are O1 and O2, is it not? O1 plus O2 minus 1 by 2 equal to 0. Okay, let me name that output as O3, which is signum of O1 plus O2 minus 1 by 2. Okay, what is it? O3 equal to signum of O1 plus O2 minus 1 by 2. Is it clear? Right, now come back to the table. See here, let us try to find out what is O3. Substitute O1 and O2, think it is visible to you. Okay, see, substitute O1 and O2 in the equation O3. See here, O1 and O2 are 0 0. For 0 0 as input, signum of 0 plus 0 minus 1 by 2, that is signum of minus 1 by 2, which is nothing but 0. When 0 0 is input, the output is 0. Got it? When 1 0 is the input, 1 plus 0 minus 1 by 2, 1 minus 1 by 2, that is signum of plus 1 by 2, which is 1. And for 0 1 as input, 0 plus 1 minus 1 by 2, that is nothing but plus 1 by 2. So signum of plus 1 by 2 is 1. Okay. So if you can see here, the XOR output is for 0, 0 and 1, 1 as inputs. The output should be 0, 0. Okay. And when 0, 1 and 1, 0 are the inputs, the outputs are 1 and 1. Got it, all of you? So to obtain this logic, the realization has been done by converting the given input pattern space into image space, and the output is obtained. Okay, that is from linearly non-separable pattern classification to linearly separable pattern classification. Is it okay? I hope you understood this, right? Now let us come back to our next step, that is how we have to draw the neural network. Okay, so see here, what are the equations? Let us recall the equations. Equations x1 and o1 and o2. What are the equations? O1 and o2, signum of minus 2x1 plus x2 minus 1 by 2, signum of x1 minus x2 minus 1 by 2. Okay, right? So for drawing the neural network, see here, what are the inputs? X1, x2. Let us confine to these two inputs. Later on we'll see what is this minus 1. X1 and x2. X1 and x2 are the two inputs. Okay. Output is O1 and O2. What is O1 now? O1 is signum of, come to this equation, minus 2x1. See here. So O1 is minus 2 into x1 plus 1 into x2, that is x2, minus 2x1 plus 1 into x2. There is another term, left out, that is minus 1 by 2. So let us consider minus 1 as another input with weight value plus 1 by 2. So minus 1 into plus 1 by 2, that is minus 1 by 2. So now what is O1 here? What is O1? O1 is minus 2x1 plus x2 minus 1 by 2. Got it? So when I apply the activation function here, signum function, O1 is signum of minus 2x1 plus x2 minus 1 by 2. Okay, next, how do you indicate this O2? O2 is signum of x1 into 1, weight is 1, x1 into 1 minus x2, that is x2 into minus 1, that is minus x2, and you have minus 1 by 2. So that is nothing but minus 1 into weight is plus 1 by 2. So what is O2 here? Signum of x1 minus x2 minus 1 by 2. Got it? So I got O1 and O2. So this particular portion indicates the conversion of the given input pattern space into image space. Okay, later on, see here, from O1 and O2, what is the equation governing O1 and O2? O3, which is nothing but signum of O1 plus O2 minus 1 by 2. Okay, so let us try to realize this, let us try to draw the neural network related to this. So what is O3? O3 is the output, final output. O3 is signum of O1 into 1. O1 into 1 plus O2 into 1 minus 1 into 1 by 2. Okay, so O1 into 1 is O1 plus O2 into 1 is O2 minus 1 into 1 by 2. So that is O1 plus O2 minus 1 by 2, which is nothing but O3. Okay, clear? So when I substitute, or when I submit, or when I when I apply the inputs 0 0, obviously the output as per the table, obviously the output will be 0. When I give the input as 0 1 or 1 0, 0 1 or 1 0, the output will be 1. When I substitute the output input as 1 1, the output will be 0. Okay, so now this is the neural network, or this is the ANN regarding the XOR gate. If you can see here, you can understand that this is a multi-layer neural network. Why you call it as a multi-layer neural network? Because you have more than one layer of neurons. So this is the hidden layer. These are the input nodes. Okay, this is the output layer of neurons. Okay, and in between the input nodes and the output layer of neuron, you have another layer of neurons. You call it as a hidden layer. What is it? Hidden layer. Okay, right? Multi-layer neural networks have at least one hidden layer of neurons. Okay, so this is a multi-layer neural network. Okay, so you can understand that we'll try to make some observations from this. So XOR, what is XOR problem? XOR problem is, it is a non-linear or a linearly non-separable pattern classification. So linearly non-separable pattern classification can be realized, okay, by using a multi-layer neural network. Got it? By using a multi-layer. So take it as granted, remember it, or any linearly non-separable pattern classification can be realized by using a multi-layer neural network. Okay, and basically this is a linearly non-separable pattern classification. And also you can understand there is another observation, that is, to realize this you need to convert the given input pattern space into image space. That's what we have discussed. Okay, right. Now the point here is, we have seen what is a single layer neural network. Okay, single layer neural networks can be realized using single layer perceptrons. That we have discussed earlier. Whereas multi-layer neural network, for training a multi-layer neural network, you need to go with a special learning algorithm, which you call it as error backpropagation training algorithm. Okay, students, my next session will be on error backpropagation training algorithm. I hope you understood this. I expect all of you will go through this lecture clearly. If you don't understand it, please try to go through it once again. This is very, very important topic. This is the basic introduction to multi-layer neural network, and how you train a multi-layer neural network using error backpropagation training algorithm. Okay, I wish you good luck. Thank you.